Okay, people, let's give a look here at the 2018 higher level question 1. So, car parking sensors are used to assist in parking. How does the ultrasonic sensor work? Okay, so you've got an emitter there that sends out ultrasonic waves. Sends out ultrasonic waves. And if there's an if there's an object there, then like a parking pillar or something like that there, if there's an object there, then the waves will bounce off it and they will reflect back and hit the collector because it's an emitter. So any objects bounce the waves back, and the time it takes tells how far it is. It's the same as sonar with fish, or with checking the ocean floor, like they send down the waves there and it bounces back off the floor, but if there's fish there, then it bounces back earlier, so they know, they can tell where the fish are. So that's A. So that's our ultrasonic. So B. Okay, so factor of safety is designing with safety margins. Okay, so the easiest example is, okay, if you're designing a stool, okay, so the heaviest guy, let's say 20 stone. So you design the stool for 80 stone. So the factor of safety is equal to 4. So it's designing stuff to be much stronger than what you think it'll need to be, just in case. So it's important for everything, particularly buildings and stuff like that. Alright, so C. Why is titanium used in surgical material? Well, the main one is it's very clean, in that, okay, it resists corrosion, which is one, but more importantly, it's not toxic. And the body doesn't react it. Because if you get a heart or a heart transplant or something like that, your body thinks it's an infection. It can detect that there's sort of new microbes or whatever in the system there. And what happens if you get a heart or a lung transplant or a liver transplant or something like that is, your own body starts to try and kill it and shut it down, but it doesn't do that with titanium. So that's why it's used for hip replacements. Okay, so that's a huge one. And also there, it's light and strong and flexible too. But anyway, loads on that. D. So modern vehicles use disc brakes. So a suitable metal for manufacturing disc brakes. Well, cast iron would be suitable. No, the one that's used there is silicon carbide. But it's expensive. Is used in Formula 1. I'll just say F1. Okay, so silicon carbide there is basically you throw carbon fiber and silicon, and it's basically like the cutting tools for the lathe there, the inserts. So it's it's very strong and doesn't wear quickly, but more too expensive for your average driving car or whatever. And another thing that can be used is aluminium alloy as well, or aluminium with this coated onto it, but basically anyway cast iron will do. Okay, so 2 reasons for the hole in a disc brake. Alright, so all the holes give you a slightly rougher surface, so it gives you better friction / grip. But another huge one then is for cooling, in that the air can circulate and cool the disc. Because these can get reddened when, if you're braking hard, you can redden the disc when the pads squeeze in on it, and heat it up there. Can go from like cold to really red and hot in seconds. So yeah, they'll do for that. And less weight as well. So F. So a brake disc and tolerances. Okay, now tolerances, I spoke about these before, and it's like very difficult to make stuff exactly. So tolerances is how big an error, I'll call it an error, but it's not really an error, you are allowed. Okay, no, they're very important. Tolerances are very important because, like, it's very expensive to make stuff exactly. Okay, so you need to be allowed to be a bit inaccurate with it. And so this question here anyway is, the brake disc is 22 thick with a tolerance of plus or minus 0.15. Okay, so that means that it could be 21.85 is the smallest. No, I'm not answering the question yet. I'm kind of using it to learn a bit. And 22.15 is the biggest. And the tolerance there then would be 0.3. So if I subtracted the small from the big there, that would be 21.85 and 22. So if I subtracted the upper one from the lower one there, so the tolerance would be 0.3. But the question they asked here is, what's the biggest it can be? So the biggest is 22.15 millimeters. Okay, so that's F. Now G. Okay, so they're looking for the shell of a football, American football helmet. Describe one suitable impact test. Okay, I'm not going to go too much into this now, but the IZOD or the Sharpie. Now, like we already looked at this there in a previous year, but the IZOD test, you just have a base, something up here with a drag pointer, a pendulum. Now that's got 167 joules for the IZOD, or 300 for the Sharpie. Basically that pendulum there, I should have probably had that longer there now. And in the IZOD, I'll just take it over here. I'll draw a bit bigger over here. Here's our notched bar, and here's the voice or the clamp. So that's the clamp. There's the notch facing the striker, I'll call it. Okay, so the notch is facing it, and the test piece is vertical. Okay, so this is so I'm going to say that we're choosing the IZOD. Okay, because the bar is vertical. In the Sharpie, I'm not going to get into too much now, but in the Sharpie, the bar would be, the test piece would be held horizontal, and the notch is on the far side. But so I'm going to go with the IZOD here and just say that. But I could have gone through the Sharpie, which is fairly similar. It's a small bit different. So here's your clamp and here's your bar. And when the hammer swings and hits it, it leaves the drag pointer at the highest point, so you know how much it got slowed down. I've gone through that before, but basically that's it there anyway. So they asked there to describe one suitable impact test. Okay, so just to finish off there, so the striker is released from a height. Because I've already said the energy here, you don't need to get into that again. It breaks the test piece. I'll just put the test piece in color here to highlight it. And this is our zoomed in view on it. Okay, so it breaks the test piece and swings past, leaving the drag pointer at the highest point. Okay, so the more brittle the higher the I'd say reading, because if it snaps easily it'll swing way past, whereas if it's really strong and tough it'll slow it down a lot and it'll only go a little bit past. So that's G. Now H. So H there, the contribution of them, right? James Dyson is from the UK. So he invented the Dyson Hoover. Now, why was that a great invention? No Hoover bags. Now that's a huge thing because the bags fill up there and they have to be emptied out, and it's kind of a pain. Whereas I think it was called a Cyclovac, something like that, and yeah. But basically, Cyclovac, and the dust goes into a container that's easy to empty. Now he also invented what are they called there? Those hand dryers, the air blade. The hand dryers. It's probably dryers in public bathrooms or toilets. Okay, so the one that you dip your hand into there with the sensors. So that was Dyson. So you only need to answer one of them, but they also asked there like Charles Parsons. I suppose I'll just throw down just one line on him, that Charles Parsons invented the steam turbine. Okay, it's used basically mostly for electricity now, that you burn coal or oil or gas or whatever and use the steam to spin the magnets that create an alternating current. So basically, yeah, that's enough on him anyway. And that Eileen Gray one, I think it's an EY, is it? Furniture design. Okay, so she was a famous furniture designer. Alright, so what is metal creep? Okay, so it's when metal deforms or changes shape due to I'll say force or load or gravity over time. Okay, so basically, like, the simplest way of thinking about it is, if you hung a weight like a bell or something, or something like that, a bell, over 40-50 years, the chain or the rope that's holding it would stretch and get a bit longer. Okay, so when a metal deforms, lead is prone to this. Okay, and higher temperatures speed this up. All right, J. What is elastic memory? Elastic memory with reference to thermoplastics. Well, elastic memory I'm going to say also known as aka plastic memory. Is when you heat up a plastic and it goes back to its original shape. So basically there, if you think about I don't really need a drawing here of this, I guess, but like there's our strip heater. Just put in a quick drawing here of our strip heater, and there's our hot wire. And so when you bend something wrong, God forbid that you ever would, when you bend something wrong, on the strip heater, then heat it up, heat again, and it straightens. So that's your example, because when you heat it up again, and I'll just put a quick sketch of a piece here. Okay, so if you bent something there and it was wrong and you decided, oh no, the angle and that's wrong. So if you put it back on the strip heater, it'll straighten, it'll just unfold back out again slowly because it remembers its old position. So, and sponges are kind of the same. When you squash them and they go back out again, that's their plastic memory of wanting to go back to the shape they were in. Okay, so that's G. Okay, K. Why is aluminium used for outdoor antennas? Because of its ability to resist corrosion. Give 2 other reasons for the use of aluminium for TV antennas. Alright, so why aluminium? Well, the main reason aluminium is used for anything is it has very good strength to weight ratio. Okay, so aluminium, for its weight, it's very strong, so that is good. And the other good things about it is it's cheap, plentiful. Okay, there's loads of it on Earth, so it's not like silver or gold. So cheap, plentiful, and good conductor. So yeah, there's loads there, I guess, in that. And L. Okay, so 2 reasons why is cast iron used to make garden ornaments. Alright, it's strong. It has good corrosion resistance. But the main one really, but how do you explain it, is it has high viscosity is the technical term. Okay, but what do you mean by that is that when you heat it up, okay, it flows like water. So it can take complicated shapes, intricate, but I don't like using words like intricate. And details. So, like low viscosity. This is kind of, that's the question answer. I'm just going to explain this. Low viscosity is like honey, or treacle, or syrup. Okay, So it has bad flow. Because it's thick. Okay, so when you melt cast iron, it flows like water, and that's what makes it good for castings, because casting is when you basically pour it into a mold and it takes the shape. So yeah, that's enough on that. And okay, so the use of electric vehicles is increasing. One advantage and one disadvantage of the use of electric vehicles. Okay, well, one of the great lies of all time at the moment, one of the greatest lies, is that there is no carbon emissions. Okay, so unlike petrol and diesel. Okay, and there isn't from the car. Okay, so if you have an electric car, it's not like you're burning petrol or diesel and releasing pollution, carbon monoxide. I'll just put that in brackets. And sulfur and all these other things. Okay, so while that is true, what people don't talk about is the fact that in making the electricity to charge it, most of the electricity is still being produced using natural gas and oil and stuff like that, and even coal. So all it means is that the emissions are coming earlier in the process rather than later. But anyway, some of the advantages. So that's supposedly one of the advantages. That's a joke, by the way, of an advantage at the moment. But because if the electricity was green slash environmentally friendly, then it would be good for the environment. Now, nuclear. Now, nuclear is like the cleanest, and it's a bit dangerous, but it is the cleanest. So anyway, that's supposedly the advantage of electric cars, and some people say they're quieter. But again, is that really an advantage when you get driven over by one because you didn't hear it coming? So again, I should be putting joker on that as well. But so that's possibly advantage as well. Disadvantages. So these are our advantages. I suppose the other one there is the electric cars is they're easier to remote control. Okay, I'll say for driverless vehicles. Okay, so the disadvantages then. Okay, we're destroying the planet, much of the planet. Digging or mining for the rare earth metals. For batteries. Okay, so Elon Musk of the famous electric car makers, Tesla, Okay, so like what they're trying to do is they're trying to find materials that are like plentiful, like silicon or something like that, where you can um, make the batteries and the transformer rectifiers and all that from silicon and stuff like that there that are plentiful and don't involve a whole load of lithium and some of these other rare metals. So disadvantages and all the mining involved in getting materials for the batteries is never spoken about. We're burning oil and gas to generate electricity. They have limited travel distances, no charging ports, in most towns and villages. Some of them they're slow to charge. They're going to demand a load of copper and other metals for to build the infrastructure. Okay, so yeah, electric cars, they might be the future, yeah, but there's a fair amount of rubbish being talked about them at the moment. So there's so yeah, best of luck with that, guys.